Hi, in this video we're going to go through 6C, further symmetry properties and the Pythagorean identity. Okay, so basically what we have here in the pink box is stuff you know already. It's just in terms of radians. So we know that in a triangle, a right angle triangle, so I might draw that over to the side, just make sure I don't have a highlighter. Okay, so we're dealing with a right angle triangle. If this is angle theta, then this angle here, because we know all angles have to add up to 180, and we've already got a 90-degree angle in the corner. So this angle here must be 90 minus theta. So basically your complementary relationships just are based on that relationship between those two angles. So theta and 90 minus theta. Now, 90 is degrees. If we're working in radians, 90 degrees is the same as pi on 2 radians. Okay, so that is just the relationship between, sine and cos. Okay, and we can also bring tan in there, because remember, tan theta is equal to sine theta over cos theta. Now, if we do have tan, usually we use the Pythagorean identity. So cos squared theta equals sine squared theta equals 1. And that comes from Pythagoras' theorem. So remember, Pythagoras' theorem is a squared plus b squared equals c squared. So when we're dealing with the unit circle, remember that we work with a radius of 1. So that's why it is equal to 1. So we have cos squared theta plus sine squared theta. So just using Pythagoras' theorem and the relationship between your angles. Okay, it also helps, before I begin, to know where we are in the unit circle. So we're still doing some questions in relation to the unit circle. So you do need to know which quadrant you're working with. So with question A, where we've got cos of negative alpha, if I've got the unit circle here, we can rewrite negative alpha as 0 minus alpha. So if 0 is here, then this is minus alpha. Okay, does that make sense? So we're starting at 0, and remember your unit circle goes in an anti-clockwise direction. So if we've got minus alpha, we're now in the fourth quadrant. And in the fourth quadrant, cos is positive. Okay, so remember A, S, T, C. So in the fourth quadrant, cos is positive. So cos negative alpha is the same as cos alpha. Okay, because cos is positive in the fourth quadrant. And if we look at our question, cos alpha is equal to 0.6. So cos negative alpha is also equal to let's start again. Cos alpha is equal to 0.6, so cos negative alpha is also equal to 0.6. Okay, let's go on to B. So sine pi on 2 plus alpha. Okay, so again, you need to think about which quadrant you're in. I might just do this in a different color. Okay, so we're pi on 2 is up here, and we're plus alpha. So we're in this quadrant here. Now, it doesn't matter, which quadrant we're in. So sine is positive in here. So if we look back up here to our complementary relationships, pi on 2 plus theta, or alpha, just represents the angle, is equal to cos, alpha. So in our question, it's also going to be 0.6. Okay, so it's just using the question to figure out which quadrant you're in, and then using the information given to work out what your answer is. So even though this is alpha, remember the two angles have to add up to 90 degrees. So pi on 2 plus alpha is the same as cos alpha. All right, question C, let me just get my pencil out. We've got tan negative theta. All right, so negative theta, we're in the fourth quadrant, so our answer has to be negative. Okay, so remember what we did with A, where we wrote 0 minus alpha. This is the same as tan of 0 minus theta. Okay, so just different angles. So that is equal to negative tan theta, which is equal to negative 0.7. Okay, so just figuring out which quadrant you're in and then working out your answer. Question D, we've got cos pi on 2 minus x. So this time we're in the first quadrant, so pi on 2 is here. All right, remember we go in a anti-clockwise direction, so if we've got minus x, we're here. And let's just look at our complementary angles. So cos pi on 2 minus theta is the same as sine theta. So in this case, sine x. All right, so in this pink box, we're using theta, but theta just represents an angle. In your question, x, alpha, and theta all represent different angles, okay? So just keep in mind that it's just a variable. All right, so sine x is 0.3. All right, let's do question E. So we've got sine negative x. So this time that is the same as saying sine 0 minus x. So we're in the fourth quadrant. So sine is negative in the fourth quadrant. So we've got negative sine x, and sine x is equal to 0.3 from memory. So our answer is going to be negative 0.3. All right, let's have a look at question F. All right, so F, we have tan, and you can see all our complementary relationships don't have tan. So we do need to work out which quadrant we're in. So pi on 2 minus theta is in the first one, so we're looking at a positive. So let me just write that down. Tan pi on 2 minus, is it theta? Sorry for tan. Minus theta. All right, so we know our answer is positive. Now, with the tangent, let's just have a look at our triangle. Okay, so let's just go back to this, because this is the first time you would have, this year, heard of cotan. Okay, so there's theta. This is our hypotenuse, opposite, and adjacent. Now, if we're looking at tan theta is equal to opposite over adjacent, tan theta is equal, cotan theta is just the reciprocal of that, so A over opposite. So when we're looking at pi on 2 minus theta, now let me just get different color in here so we can see it on our unit circle. We're at pi on 2 minus, so we're here, and that is theta. But we need to use the reference angle here. Okay, so we need to use its complementary. So even though it wasn't written in our little pink box, okay, so it might be worth adding. So tan is opposite over adjacent, and cotan is just the reciprocal of that. So tan theta, in this case, opposite over adjacent, and if we look back at our question, it's 0.7. So if I was to write that as a fraction, it would be 0.7 over 1. Now we don't tend to write decimals in fractions, so I'm just going to convert that to integers. So 0.7 over 1 is the same as 7 over 10. So cotan is just the reciprocal of that, so 10 over 7. So when you're doing F, it's cotan theta. All right, so you might want to add that in because it's not written in that little pink box there. All right, let's have a look at G. do that over here. So we've got cos pi on 2 plus x. All right, so pi on 2 plus x, we're in the second quadrant, so pi on 2 plus x. So let's have a look at our complementary angle. Pi on 2 plus theta, negative sine. Okay, so we're going to have negative sine x. Now sine x is equal to, from memory, 0.3. Let's just scroll up, 0.3. So it's going to be negative 0.3. All right, and did we have any other tans? Did we do C? Yeah, we did C. Sorry, H and I. I was just seeing if we had any other tan questions that we could practice on. All right, H is sine pi on 2. I didn't see what the angle was, minus alpha. So we look at the complementary angle. So we go back up to the pink box. So cos theta, so because we're using alpha as our angle, it's going to be cos alpha. And cos alpha is equal to 0.6 from memory. And let's just do the last one. So I sine 3 pi on 2 plus alpha. Okay, so even though we don't have those relationships in here, we can look at our unit circle. So 3 pi on 2 is down here. And we want plus alpha, so we're in the fourth quadrant. So alpha here. So that's going to be equal to, now because sine is, sorry, what are we doing? Cos is positive. So it's going to be equal to cos alpha. And cos alpha is 0.6. Actually, sorry, just with I, it should be negative 0.6. So even though cos is positive in the fourth quadrant, okay, so let's just go back up to our unit circle. So in the fourth quadrant, cos is positive, but we're saying, the question is saying, well, sine is positive. So to allow for cos to be positive, it has to be negative here, if that makes sense. So we're kind of doing the opposite sign. So negative 0.6. All right, question 2. So in question 2, we've got now a range. So remember with cos and sine graphs, cosine and sine graphs, they're infinite. Okay, so they keep going on forever. So if I was just going to draw a cosine graph, all right, it goes like this and it keeps going. What this is just saying is we are restricting the domain. So we're going from 3 pi on 2 to 2 pi, which is the same as 270 to 360 if we were working in degrees. So we're only looking at a certain quadrant for each one, all right? So it's important to look at the domain. You don't have to relate to the graph. We're going to go back and do the unit circle, but it's basically saying which part of the unit circle we're referring to. All right, so let's draw the unit circle again. All right, so we're at 0, pi on 2, pi, 3 pi on 2, and then we're back at 2 pi. All right, so for question A, we want cos x equals 3 over 5. Now, there's two ways you can go about these questions, and it just depends whether they're Pythagorean triads or not, which will make it a little bit easier for you. And looking at them, they look like they are. So first of all, with question A, let's decide which quadrant we're in. So we're looking at 3 pi on 2 to 2 pi, so we're in the fourth quadrant. All right, so remember cos is positive in the fourth quadrant and sine and tan are negative. All right, so if you want to write negative and negative there. Now, if we were to draw this as a triangle, all right, so I'm going to do it two ways. Let's just call this theta here. It doesn't matter which side you called theta. It's just when you do your adjacent and hypotenuse. So remember your trig ratios, cos theta is equal to adjacent over hypotenuse. So 3 is here, 5 is your hypotenuse. Now, if you're familiar with your Pythagorean triads, you would know this one is 4. So that means that sine x, which is equal to opposite over hypotenuse, your opposite side is 4, and your hypotenuse is 5. Now we are in the fourth quadrant, so sine is negative, so it's going to be negative 4/5. And we have to do tan. So tan x is equal to opposite over adjacent. So your opposite side is 4 over 3, and tan is also negative in that quadrant, so we're going to have negative 4 on 3. Now you could also use, let me just scroll up, your Pythagorean identity. Okay, so you could use this. All right, so let's just solve one of them because I don't want to be here forever. So if I just rewrite it, so sine squared theta plus cos squared theta equals 1. So if we've got cos, so we've got sine squared theta, oops, undo, equals plus cos 3/5, so we square that, equals 1. All right, so sine squared theta, if we're square, oh god, I did equals this again, sorry. All right, so let's just square that fraction. So we square the numerator and the denominator. So we're going to have 9 on 25 equals 1. And then let's just go ahead and solve this. So it's going to be 1 minus 9 on 25. So we've got sine squared theta equals, so 1 minus 9 on 25 is negative 16 on 25, and sine theta, we take the square root, whoops, sorry, that's not minus, it's plus, the square root of 16 on 25. Now if we're taking the square root, we want plus or minus, two solutions. So sine theta equals 4 over 5. And we're just got to decide whether we're positive or negative. So remember, we're in the fourth quadrant where cos is positive, only cos is positive. So ASTC. So that means we have negative 4/5. So you could either use Pythagoras' theorem, or you could, if you knew your triads, you could do it that way also. All right, it seemed like such a long question, but there was two ways of doing it, so I guess it was useful. All right, let's have a look at question B. So sine x equals 5. You will not be able to undo this action once it's... I don't think Word is liking me using the writing on here. Anyway, let's keep going. So sine x equals 5 over 13. So if we were to draw that as a triangle, very poorly drawn triangle, so let's do theta there. So sine ratio is opposite over hypotenuse. So this side is 5, this is 13. Now, if we were to use Pythagoras' theorem, we can work out this side down the bottom. So 25 and 100, so it's going to be 12. All right, so 3, 4, 5 is a typical Pythagorean triad, but 5, 12, 13 is another one. And then you've got multiples of them. So if we're doing cos x, we've got adjacent over hypotenuse. So 12 over 13. and then we just decide which quadrant we're in. So we're at pi on 2 to pi, so sine is positive, so that's going to be negative. And then let's do tan. So opposite over hypotenuse, so 5 over 12, and tan is also negative in that second quadrant. So you can draw your triangle, and looking at all these problems, they all look like they've used Pythagorean triad. So even if we have a look at G, 8, 10, we're just basically multiples of 3, 4, 5. Okay, so remember that. Well, let's do C. Just wondering if that is a triad. It's got a 1 in there, 1/5. All right, so if we were to draw the triangle, so we've got adjacent over hypotenuse, so 5, 1. Yes, that would make that 2, wouldn't it? 2 squared plus 1 squared. No. Let me just quickly do that. So that would be Okay, so C is 25, so we've got 1. Yeah, so A is equal to square root of 24. Okay, so it's slightly different this one, but you could still use the triangle. So that means sine x is equal to root 20. Oh, did I do it around the wrong way? I did. Sorry, just bear with me. Just put my 1 and the 24 around the wrong way. So do 1, 24. Okay, so we've got root 24 on 5. And I didn't check which quadrant we're in, so we're on from 3 pi on 2 plus 2 pi, so we're in the fourth quadrant. So only cos is positive, so that's got to be negative. And then tan is opposite over adjacent, so it's just root 24, and it's also negative in the fourth quadrant. All right, I was just looking at the answers, and I probably should have simplified this third. So the highest square number that goes into 24 is 4, so we can rewrite 24 as 4 times 6. So A is equal to 2 root 6. So here I should have had negative 2 root 6 on 5, and here negative 2 root 6. All right, so just simplifying that third. All right, do we have any? Oh, I think that's where I probably should save it. Keep going through these. Okay, so I think it's easier to draw the triangle than use the Pythagoras' theorem, but you still get to the same point. So choose what is easier for you, but remember you've got to do your answer in the correct quadrant to determine whether your answer is positive or negative. All right, bye.